Hello Superuser, so today we're going to be continuing with the third video in this series of how to code with JW Lua. Now if you're finding these video series helpful so far, make sure to share it with all your friends and hit the like button so I know to continue making these videos. And last time, just a quick recap, we learned how to change the note head character for a bunch of different notes in a selected region. So today we're going to continue on that by adding one more factor, and that is how to change the character based on the pitch. So without further ado, let's get on with it. So we've been learning a lot so far in Lua. We've been learning for loops, we've been learning variables, and so now we're going to be learning a little bit of logic, and that is with the if-then statement. So how it works is you have if, then some sort of statement. For now we're just going to say true. Then in here we can do whatever we want. So we can print like hello, like that, and then we end it. So now if we were to run the code, it outputs hello, because if this statement is true, then we do whatever is inside the code. If it was false, however, it would not run this code. It would run whatever's after it. So print this will always run, like that. So if we were to do that, this will always run, but this inside will not run because this is false. So how if statements work is we have some argument in the form of if true, then we can do whatever we want. So we can print like this runs, and then we go and we end the code like that. Now it's important to note that after we end the code, anything here will always run like normal. So we can say this will always run, like that. So if we hit run now, this runs, we can see this runs, and this will always run because that always runs. And it runs because the statement is true. If the statement were to be false, like that, then this code doesn't run, but everything after it runs like normal. And like everything else we've done, we don't actually have to hard code in true or false here, because that can kind of get annoying, and that takes away the value of the if statement. So we can actually even put a variable in as the if statement. So we could say local myBool equals false. We replace it with myBool, like that, and hit run. It doesn't work, but if we change that to true, then hit run, and it runs. So that is only the tip of the iceberg, though, with if statements, because we just learned how to pass in if statements with booleans, right? But really, we can do other cool things like this. Like we can actually tell if an item exists. So let's say we don't have a variable over here, but we have, remember our example pizza, where pizza didn't exist to return nil. Now if we were to run it with pizza instead of a boolean or a variable, it will not run, because remember pizza is nil, and nil is like it doesn't exist. So we can even say nil here just to prove a point, and it won't run. So if statements are also a really easy way to tell if an item exists or not. So the final cool thing we can do with if statements is something called relational operators. So what relational operators are fairly simple things. So we can do things like, is 2 greater than 4? Obviously it is not, so it won't run. But 2 is, however, less than 4, so it will run. There's other ones like we can see if things are equal to each other. So we use double equals to check for equality, because remember single equals is assigning a variable. So we can say if 2 equals 2, then it runs. We can even do strings in here, so we can do a string of 2 is equal to a string of 2. It'll run. There's a couple other ones, like we can say less than or equal to. So is 3 less than or equal to 3? If so, it'll run. If it's not less than or equal to 2, it won't run. So here's a quick list of all the different relational operators we can use. So we can use, again, equals equals, checks to see if two values are equal to one another. Not equals, that's a tilde. Not equals, checks if two values are not equal to one another. So 2 is not equal to 2 would return false. Another one is greater than, to check if the first value is greater than the second. Another one's less than, to check if the second value is greater than the first. And then there's greater than or equal to see if the first value is greater than or equal to the second. Or less than or equal to see if the second value is greater than or equal to the first. And so with that said, that is how you do this through Lua. So this is how you would then do it through Lua. So let's see how you use if statements in a JW Lua environment. So that's how you use if statements in normal Lua, but let's see how you would use it in a JW Lua environment. So we're going to use this excerpt from PureGint to help demonstrate how we can use if statements to change the character based on the pitch of a note. So just to recap real quickly, last time we wrote this script, which will change every single note to a note head of X and size 80. In the end, we're going to modify the script just a little bit. But first, let's just hollow out on the inside, so we're still looping through every entry in the region. And let's add some code. So we're going to say local highest note is equal to entry dot calc highest note, and we're going to pass it an argument of nil. Remember, this is so far the same as we started with last time. Then we're going to do something new. We're going to say local of MIDI is equal to highest note dot calc MIDI key, just like that. And then just make sure that we're understanding what's exactly going on. We're going to print MIDI like that. And so what this should do is it should take the highest note in every single entry through here, and it should just print whatever the MIDI note is, like usually from 1 to 88. That's the different keys on a piano. So let's try this out, and we hit run script, and we see it attempted to call method highest note, yada yada yada. We have an error because, whoops, looks like I made a typo. It should just be highest note, not highest notes. So let's run script now, and we can see it is giving us the MIDI key. So the B natural is a 59, the C sharp is 61, which makes sense because it's a whole step higher, until we get to this error message. Now the error message reads, attempt to index local highest note, a nil value. And we can see it's happening on line 9. So basically, calc MIDI key is not finding that function on highest note, because highest note doesn't exist. So what does that mean? Let's go through here and just see which note is causing this error. We have 59, 61, 62, that's the first three. Then we have 64, that's the E, 66 F sharp, 62 is D natural, 66 is F sharp, and then we have it like this. And for those of you who saw the footnotes last time, you'd be like, oh, I know what's happening. If you didn't, what's actually going on is each entry saved goes through every single entry, not necessarily every single note entry, which means it's counting the rest as a note entry, and rest don't have a highest note. So let's add in here an if statement to only pass through any entries that are a note. So we already know that highest note will always be defined if there's a note, and it won't be defined if there's not. So we can have an if statement called if highest note, then, and then we can put that code in the middle and end like that. And so this block of code will only run if the highest note exists. So now if we run the script, it should give us no errors and it should go all the way through. And that's really cool. And so what if we try now to find only the notes above a middle C? Well, how would we do that? Well, we already have the MIDI, which is the actual note pitch of the note. And so now we just need to filter out all the notes above C, whatever her C is. So if you find the first note is a B and that is 59, that means C must have a value of 60. So now after we have figured out what the pitch is, let's add in another if statement here and say if MIDI is greater than 60, then we'll run this code and we'll hit end. Now if we were to hit run script, we should only see values that are higher than 60, which means these are only the notes above middle C and not including middle C. And look at that, we're actually almost there to changing all the note heads by sound of pitch, because now we've isolated all the notes and we've isolated all the notes above a pitch, which means instead of printing out the note, we can actually just paste in our code from earlier on how to change the note character, and we know this code will only run if the note is above middle C. So now if we were to hit run script, look at that. Only the notes above middle C are X's. That's really cool. And conversely, we can say like all the notes less than or equal to middle C, so that should be all the other notes, turn in an X. That is really cool. That is what we're going with. That is why Lua and JW Lua can be really, really powerful, because it can make decisions on the fly for things that you'd normally have to do. That's what Finale script cannot do. That's what can save you a ton of time, is the logic from if statements, for loops, and variables. And we can see this code runs in less than 1,000th of a second. So where do we go from here? Well, like every week, there's some homework to help you get more practice, and that way you get really comfortable with what's going on here. So the first thing to do is to change all notes below middle C. Oh, looks like I already gave this one away, so maybe you've got it off easy. The second one is to change all notes above middle C, including middle C. Remember before, we weren't including middle C. I'd recommend trying to use the greater than equals to operator rather than changing the actual value that you've hard-coded in for middle C. The third one is to change all the C's in every octave and only the C's to an X note head. So we can see that we have a C that's an X note head, a C that's an X note head, and none of the other notes are an X note head. You're going to want to see the modulus operator footnote to specifically figure out this one out. And then finally, we want to change every other note to an X note head. Again, you're going to need the modulus operator, and you're going to have to apply more critical thinking. So we can see X, not X, X, not X, X, not X, all the way through. And it's skipping over the rests. So we still have x, not xx. So again, that's a quick summary of all the homework. Make sure you put the solutions in the comments below. I will give feedback if you put them there, so feel free to do that. And then we have the footnote videos. So the first one is, what is debugging and how do you do it? We already experienced a little bit of debugging with trying to fix that one error, where highest note for some reason was a nil value. That is one example of debugging, but here's more examples for debugging. Then we have the introduction to the modulus operator. That is going to help you get through the homework. Finally, what does the dash dash mean that I keep using in Lua? Like you see up here, I use dash dash. What is that actually doing? And then we have some cool things you can do with if statements and for loops. And then finally we have if, then, and else. Because we've only been focusing on the if, then, but there's actually a third attribute you can use called else. And so that is it for this week. Next week we're going to focus on some best coding practices. Next week and the week after are going to be to the two most important videos in the entirety of the JW Lua series that we're doing. So definitely do check those out. Definitely do subscribe and ring the bell button. That way you get notified when each of those videos comes out.